All right. So there are a couple things I want to offer up as preamble. One is first that I've kind of dated myself with the topic of this, which is a web counter. And some of you may not know what a web counter is, so let me talk about that. When the web was new and exciting, HTML is kind of the markup language for creating a web page where you create titles and so forth. And it was relatively easy to learn. So there was tremendous excitement in people being able to put up their own web page, create a little HTML. And the name of the game was that your page had to get attention. So you had to use the orange and the green font, and you had to have the blinky things, and you had to have the little hamsters dancing in place. And if there were 100 hamsters, that was like 100 times better. And in order to kind of have bragging rights that people were actually coming to your page and looking at your yarn collection or whatever the hell you're displaying on it, that there would be a counter there, typically at the bottom of the page, saying there have been 3,682 visitors since January 1st, or something like that. So that's the web counter. It's something that's just giving a running total of visitors to the web page. Taking a step back, why have I taken the effort to create this silly email rather than just telling you what to do? And one of my beefs about programming classes in general, and I think the entire undergraduate program suffers from this to a certain extent, which is you'll get a paragraph or several paragraphs description telling you what you need to do. Right? You need to code up this kind of list, and it has to have these features, and it has to do this, that, and the other thing. My problem with it is that the instructor has done all the hard work of approaching the problem and figuring out the problem that needs to be solved. They've done all that work of thinking about the problem, and now they're telling you what to code up, right? Where I'm trying to say that isn't how it happens in the real world. You don't get 3 paragraphs telling you what to do. You get 3 customers who only halfway know what they want, and it's a little ambiguous and confusing and so forth, and you actually have to go through a process of solving that problem. Now, I'm a little bit constrained by the fact that we're actually still kind of learning the language, and I can't bring you into the equivalent of a boardroom and give you this the scheduling application for the university, right? That's obviously well beyond where we're at right now. But I want to chip away at that a little bit and kind of present things just a little bit vague, a little bit more realistic, so that we can at least kind of start modeling what it looks like to actually solve problems in the real world. So that's the motivation for giving you an email, because we're getting real. Now, looking at the content of the email itself, I want to start by focusing in on this little saying they have here, talking about abstraction and encapsulation. And let me start with, let me call this OO basics. So abstraction is describing something in terms of how it's used. So the one thing that this email discusses is a web counter. And tell me how we use a web counter. It's definitely not meant to be a trick question. All the information's there, pretty laid out, pretty straightforward in the email. What are the things that you do with the web counter? Describe this thing in terms of how you use it. What do you do with the web counter? Okay, every time the website's open. So take the website out of it for a moment, and let's look at the web counter itself. So the website, you're right. The website's going to interact with this web counter. What are some of the interactions with that web counter? What will the website say or do with this web counter? Add one. What phrasing is used in the email? Huh? Increment. All right, I'll stick with that. So what does that mean? add 1 to the counter. What else do we do with the web counter? Reset it, and reset it will set the counter to 0. What else? Set. Assign a particular value to the counter. And what was the other one? Get. Retrieve the current number of hits. And now that we've said that, give me something. Thank you. We'll go with hit instead of increment. All right, so that's pretty easy. That is describing a web counter in terms of how we use it. Now, it seems so straightforward. I don't think we're appreciating exactly what I mean about describing it in terms of how we use it and what that actually means for having a web counter in our application. So in order to really drive this home, I would like to ask for 2 aspiring thespians who would like to come up and play the role of web counters. I know that there's someone who majored in drama, who had drama classes in high school. I didn't. I was too shy. I would have been terrified at the prospect. But I know someone out here has it, and maybe if you haven't, it was like you always wish you did. This is your big chance. This may be your break. There are scouts in the audience. You don't have to raise your hand. You don't have to, there's no application process. You merely have to stand up and walk to right there. I'm willing to wait 20 minutes. All right, thank you. There's one. Someone has broken the ice. All right, it's always a little awkward at the beginning of the cocktail party. Now the music's on and feeling a little loose. There's one more of you up there. Come on. All right, yeah, all right. We have our 2 volunteers. Okay, so you will be recorded, by the way.
Is there time to sit back down?
You like rehearsal time.
This is your rehearsal. All right, there we go. Thank you. And I'm going to give each of you one of these. And could you go ahead and for everyone let us know your first name?
My first name's Jarrell.
Jarreau?
Jarrell.
All right, Jarreau.
Brady.
Jarreau and Brady. All right, so Jarreau and Brady are our web counters. We can imagine I'm the application and I've created these 2 web counters, right? This is the same as creating 2 students. You can imagine 2 lines of code in there where I brought Jarreau and Brady into existence. Now, what are the things I can do with Jarreau and Brady? Hit, reset, set, and get. Yeah? All right. Let me say Jarreau, set 0, Brady, set 0. So you can use this. This would be the piece of paper there represents kind of your information or your data. So you can go ahead and just put a 0 on there, maybe in the upper left-hand corner. Make it big enough so that everyone can see it when you hold it in front of you. Feel free to hold it in front of you. All right. So now I'm going to say Jarreau hit. What is Jarreau going to do? Add 1. So go ahead and add 1 to that. Okay, Jarreau hit.
+1.
Yep. All right. Brady set 42. What else? Jarrell reset. Note the dramatic pause I introduced there. Okay. I've done this before. I've done this play once or twice. Wait, line? No. How about this? Brady, get. What happens? Right. And I think a key phrasing there is tells me, or let me just use a slightly different word, gives me the number of hits. Okay? Brady does not have a C out to the screen. All Brady does is, let me use C++ terminology, returns to me the number of hits. It's up to me to do something with that number. So Brady, get. No. We got a bug in the program. When I say get, you return the 42 to me. Now we don't know, we aren't quite sure how that in human terms works. I think tell is the equivalent of return. So I say...
Is that equal to 42 hits then?
Yes, that is
Okay.
42 hits. So when I say Brady get, then you go ahead and tell me 42, right? You don't. You can actually, let me say it or sing it.
42.
All right. Okay. So 42. Now that I have the 42, it's up to me to do what I want with it, right? Now, given the application, I'm probably going to get it up there on the web page, but I could do mathematics with it, add numbers to it, or write it to a file. But that's up to me, the application. All I know are the four things that I can do with my web counter: get, reset, set, and hit. How about this? What if I say, Jarrell, set -99? What do you think? Everyone good with that? That should not sit well with at least one of you, and why is that? Right, there's a context here, right? This is supposed to be a hit counter, the number of visitors to a web page, and you'd never have negative numbers of visitors to a web page. So this, as simple as it is, this is the kind of thing that happens, when you are pulling apart problems in the real world, which is you notice something that hasn't been talked about and there's no clear answer. What should we do if an invalid number is provided to the set function? And depending on the severity of the problem, you as a programmer may make an executive decision, or you may have to go back to the customer and have a discussion and say, well, we found this kind of situation where this can happen. What should we do? Should we generate an error? Should we set it to 0, right? So for our sake, I think we'll go with the common sense approach and maybe just say that if a number less than 0 is provided, then we just set the value to 0. The web counter will. All right? So go ahead, and when I say negative, whatever I said, -99, you go ahead and just make sure your counter is set to 0.
Yeah.
Okay. There's another aspect to this, which is the encapsulation. Remember, there are two words, abstraction and encapsulation. Encapsulation has two pieces of it. One is a bundling together of data with the behaviors that operate on that data. Putting together that, it's literally where the word encapsulation is coming in, putting in the same capsule data and the behaviors that operate on that data. So the data obviously is very simple. It's a single number. And then there are 4 behaviors that operate on that single number. The second, so let me contrast that with Project 3 with the hero. There was no concept of a hero had a name, and maybe the hero had gold or hits, and it all, of course, depended on the kind of adventure you came up with. But there's no concept of behaviors that operated on the hero. The hero was nothing but data. Okay? The second part of encapsulation is that the only way that anyone outside of a web counter can interact with the web counter is through the provided behaviors or through the provided interface, meaning that the only things I can do, hit, reset, set, and get. Nothing else am I allowed to do. I do not have access to Giroux's data. If I reach in there and I try to change it, just slap my hand away. That's not illegal behavior for me to be changing that data. And if he has anger issues, he'll pummel me. Okay? But the point is that all I can do are those 4 things. I do not have access to that data. All right? And this is very different from the hero in Project 3, where that is precisely what you did. You went in there and you set that data directly. The same as the test question that I wrote out. We had FDSA equals 90 is what I typed in. I was working with the student's age directly. If we were dealing with encapsulation, then there'd be behaviors associated with that student, and I would only be able to use that student through those behaviors. I would not be able to touch the data directly. Does this make sense? Okay, and so that's why I brought them up here, is to show that it's their data. Only thing I've got are the 4 interactions with them. That's how it works at the programming level as well. Now, keep in mind as a programmer that you've got 2 different roles. You have a role being the developer of this Webcounter, and then you have a role of writing an application that uses the Webcounter. When I'm actually writing the Webcounter, I'm creating the source code to the set function and to the reset function and the hit and the get functions. And so I'm writing code that's manipulating the Webcounter's data, right? But as users, any application, a main function, or any other function I write that tries to create a Webcounter and use a Webcounter, only through those 4 functions. All right, that's all I have there. Thank you very much. I appreciate you volunteering. So for the sake of the notes that are going to go up, let me go ahead and say encapsulation. The bundling together in the same capsule. Data with the operations that, well, let me say with the behaviors that operate on that data. Okay. That's part 1. Part 2 is 1. Two. Access to, well, let me see. Data is only accessible to the behaviors. Outsiders, or about those outside. A little inelegant, but hopefully that gets the point across. All right. 4 functions. So what I wanted to do is start looking at that at a coding level. Let me see. I guess I can do basics.cpp. And let me go ahead and start with what we had from Project 3. We had this idea of a structure, and the hero might have gold and number of vinyl records. One of our gray-bearded heroes. What else? It doesn't matter. We'll just leave it at that. And then we would actually create our hero here. I guess I will be the hero, as modest as I am. And in order for me to manipulate Todd's data, this is the syntax for it. 100 because Todd is solid gold. I wonder just how long I can make the Todd puns go, and I don't have to do any actual work up here. Just all right, and we'll say they're about 33 and a third. 33 and a third. It's not a float, but what's the significance of that? Anyone? 33 and a third with vinyl records? The speed of rotation of a vinyl record. It rotates around 33 and 1/3 rotations per minute. All right, that'll help you when you're in a bar at some trivia thing. Can't say you didn't learn nothing in here. All right, so you can access the data directly. And by analogy, if we did that role play up here, and the analogy would be if the person I had standing up here had that piece of paper held to their chest, and when I would do line 12, it would be akin to me walking over with the pen and scribbling out what was there, if there was something there for the gold, and putting 100 there, right? And there'd be another entry on that piece of paper for number of vinyl records, and me going over there and putting 33. You don't necessarily have to modify it, right? I could do something like this. And here I'm merely accessing the information. I'm not modifying it, but it's the equivalent of me going over, and I'm not doing any interaction with the person standing there per se. I'm just walking up and putting my face near the piece of paper to glean what the number of gold is, and then I take that and spit that to the screen. So that's what that model is. We're now looking at the Webcounter, and it has a very similar syntax in describing it. I've got the open curly brace, I have the closed curly brace, and for the life of me, there we go, and a semicolon. And then we list all the data in the Webcounter. Now our Webcounter only had one piece of data, and we can call that whatever we want. I think one that visitors. So an integer representing the number of visitors to the web page. This will make it plural. But we can also put in here functions. Now what I'll do is I'll go here, and I'm just going to grab this information so we have it to refer to, and I'll just put them each in a comment. So those are the behaviors that we had with our Webcounter, and we can put those in here as well, and we can put them as functions. So we have hit, and this is incomplete information. Let me say that right off. I'm going to come up to each of these four, and we're going to add some more information to them. All right. So every function that I ever create in the language has three things, and those are the three things. The x's are what the function is giving back to us. The y's comprise the name of the function, and the z's are the input parameter or input parameters. Okay? So we've got the y's for each of these. What we need to do is fill in what each of these is giving back to us and any input parameters. I think hit is a real easy one to start with. When I turned to one of our role players here and I said hit, did they give me back any information? No. So I would say void. Did I provide any information? Did I say hit, and by the way, here's a very pretty picture of a house I drew, right? Did I give them anything? No. So I could put void there as well. Now this may look a little alien. The equivalent of not having any input parameters is just to leave that empty, and that we're more accustomed to seeing. So I'll go with what we're doing. But just to let you know, it is perfectly fine in the language to say, hey, there's nothing in there. Reset, very much the same way. They gave me nothing back, and I provided nothing. How about set, though? Did I provide any information when I said set? Yes, absolutely. What kind of thing? What was the type of thing that I provided? An integer, yes. And doesn't matter what I call it. I'll say something like that. Did I get any information back? No. And then how about finally with get? When I said get, was I given anything? Yes, I was given an integer, and I didn't provide any information. Okay, so that's the way those functions look. Now, so you can see right away there's quite a similarity with the struct hero on lines 1 through 4 with what I would call, this is what I would call a class declaration. All right, this is the class declaration. This would, by the way, be the structure declaration. However, coming back to this write-up here, I need a way of representing encapsulation. Now, I have the first part, the bundling together in the same capsule. That's what we just did. We just put the data and the functions together in the same capsule. So this class and the curly braces, that's kind of the capsule that's putting those together. However, part 2 is what we still have to do, which is we're only allowed to access this thing through the behaviors. Now, I mentioned it last time that if the way encapsulation works is if I was to go in and try to use a pen to change the number of visitors on one of my web counters up here, I would be unable to do it. Okay? And the way to specify whether or not you're able to access something are with a couple keywords, public and private. And so everything below public are things that the outside world, meaning in the context of the web counter in this role play, I was kind of the outside world. The only things I could do were those 4 public things there. And I do not have access to visitors. Okay. We can go ahead and write a little code. And what were the names of our web counters? Was it Brady, and is that right? And Jarrell? Is that Jarrel? Right. And of course, Brady is. Right. So there I create my 2 web counters, and the things I would do is I would say, maybe I'd say reset. I probably said that to both of them. If I didn't, I should have. And then I might have said hit, maybe Brady, I said set to 32, and then right, so there I am kind of using these things through their public interface. I can compile this. Now, let me be the first to say things are incomplete. I have yet to describe what these functions do. Now we can look at those and intuit, particularly based on what we did on Monday. However, to say generically that there's no way you don't have the slightest idea what these do. If I showed you this and these were the function names, then you go, yes, you're absolutely right. I don't have the slightest idea what they do, right? This is just showing us how we can use them. It doesn't tell us what they do. So despite the information being incomplete, I'm going to compile it. I can't create a running application, but I should have enough information here to turn this to machine-readable code. And I would only be able to turn it into an application if I actually wrote out these 4 functions and compiled those as well. So what I'll do is I'm going to provide a, I'm going to change this prompt since I don't have a lot of real estate. This is oobasics.cpp. The -c option means I will only try to take this code to be machine readable, but I won't try to create a running application. And it doesn't like cout. So I've forgotten to say count include IOStream, and I want to very easily use every single thing in the standard library, so this is kind of my blanket command to get away with that. Let's try it again. And there are no errors. So this code is all fine. Now let me show you what I mean by the enforcing encapsulation and that I'm unable to access the private data. Note the way that I'm accessing my hero here. If I try to access one of these web counters directly, like here I say Brady.visitors equals 99. There I'm trying to access the data directly, and I try compiling that. Let me clear the screen. Okay, we get an error. So the way encapsulation is enforced is I am unable to create a running application if I make any attempt to access that private data directly. So there's the enforcement of data encapsulation. Any questions to this point? Yes?
Class constructors.
I'm not going to talk about constructors yet. Stay tuned. Yes? Yeah. The double colon. Do I have that yet? All right, that's the next thing to talk about. So, as I said, we don't have yet, I have yet to write these functions here. The set, the reset, the hit, the get. So let's go ahead and do that. This is the class declaration. It is typically found in a header file. So I would normally put this in a file called webcounter.h. When I write these 4 functions, I would put them in a source file, and I'd call that the class definition, the definition of the class's member functions, typically in a source file. And I would normally call that webcounter.cpp. Now the first thing I would have in this file would be include webcounter.h. I'll comment that out since I've got everything obviously crammed into one CPP file, but if I split out lines 19 through 28 into webcounter.h, then I would need line 34. And next, I want to do the set the get function. So that gets this is our way of defining or describing functions, and now in our brave new world this is not quite enough information because the compiler looking at line 36 does not realize that that function is actually part of Webcounter. So we need a little bit more syntax sugar to explain to the compiler that it is part of Webcounter, and the syntax for that is to put the name of the class in 2 colons. And note that the name of the class in the 2 colons butt up against the name of the function. A early mistake that folks use is to put it right at the beginning of the line against the type. It doesn't go there. The information you're trying to describe to the compiler is where the function name belongs. That function is part of Webcounter, so that's why that appears there. So that's the purpose of the 2 colons. And now there's probably, I'm guessing, somewhere between 50 and 75 lines of code that goes right here. Give me, I kid. Give me 1 line of code that goes right here. That's it. Now, there should be some extra credit if you can come up with a way to stretch that into 50 lines. So. This is, and I think right here on 38, this is the hardest thing for people to get their heads around. The most intuitive thing in the world is for me to bring 2 people up here and interact with them as web counters. And when I say get, and they give me the 32 back, everyone's thumbs up. That makes complete sense, no problem there. But when they look at this code, they see line 38 and they go, visitors, where the hell is visitors? I better provide that as an input parameter. And this would be like with my 2 web counters standing up here. If I say get, and here's the number 32, and they go, oh, here's a 32 back at me. Right? You see how silly that is? I don't say get and give them a number just for them to give it back to me. They have that number. When you're walking around on campus, you have a name and an address and a GPA and the current classes you're taking and whatever the data is that comprises you as a person. A web counter has, every web counter you create will have a visitors variable. That's what the purpose of line 27 is to describe what every web counter, should you decide to create one, will have. Those 4 functions and that piece of data. Okay? All right. Other questions? Let me just do a courtesy look here. No anonymous questions. All right, so let's look then at what I have in store for you on the web page. If I go to assignments, assignment 13, the implementation of the web counter. So there's an attached file. Let me go ahead and click on that, download it. Oh, looks like I had it. And there's a command here provided to extract it. I'll go ahead and extract it. tar z, the f, a13. All right. The x means, the v means be verbose. Normally these commands work silently. If I leave off the v for verbose, here's what the command looks like. So the verbose makes people feel a little bit safer, I guess. The X means it's extracting these from the archive. It's creating an A13 directory, and in the A13 directory, it's put 4 files. So let me do an ls. There indeed is the A13 directory created. I'm going to clear my screen so that we go to the top. cd A13. All right, the make file has been provided. To build this thing, all you have to do is type make. Let's look at webcounter.h. Hang on. That doesn't look quite what I was expecting. It isn't. That's the completed assignment there. All right, hang on. A13.tar.gz. Let's do the tar command. ls. There's a, all right, A13. Webcounter.h. Okay. So there's only a comment in there. It says write the class declaration for the Webcounter class. That should be pretty easy because it's right there on the left pane, lines 21 through 28. I pretty much did that. So you could essentially copy and paste that in there. You do need, recalling our work with header files previously, you have to put the header guards at the beginning, the pound if and def, webcounter_h, pound define, and then pound end if at the bottom. So you have to add that, but otherwise, what you see on the left pane is all you need in there. There's a webcounter.cpp. Let me zoom in on this. So write the member functions for the Webcounter class. We just wrote the get function. There are three more, the set, the hit, and the reset. And then there's a bit more information here. I'll talk about that right about now. So what you need to do is you're each individually required to submit this assignment. However, for these smaller assignments, you know that I encourage you to work in groups. You can choose whatever groups you want. Doesn't matter. So it says place class declaration. We talked about that. Write the 4 functions in CPP. Then you can test it using the pre-written test program. So if I look at test counter, then what does this includes? You'll note that I included webcounter.h. If you forgot to include header guards, it's going to throw up on line 4. So that's just my little test to make sure you include the header guards in your header file. There's IO stream. There's creating a web counter object. We reset it to 0. And then we print out, we call the get function saying now your web counter should have a 0 in it. That confirms it. Set it to 25. Confirm it. Set it to -8. We talked about that. If you pass in a number less than 0, let's just go ahead and set the number of visitors to 0. So there's the test of that. A couple hits, seeing that it went up to 2, and that's it. So after you write the header file and the source file for Webcounter, you should just be able to type make. I don't have anything in there yet. And it'll compile just fine. And you can run it and test it. All right? So that's the whole first part. After you get Webcounter working, there are 2 more member functions you have to add. One to load. You give it a file name, and it will read in. Let me start with save. You provide a file name to the save member function. So you already have 4 member functions, hit, set, reset, and get. You're going to have 2 more, load and save. With save, you provided a file name. It's going to open up that file for writing, and it's going to write out the number of visitors. Okay? Load takes a file name. It'll open up that file for input and read in a single integer the number of visitors.